Hello friends, welcome to Coding Garden with CJ. Welcome to Higher Order Functions. Today we're going to talk about ForEach, map, filter, and reduce. I have the very special Mr. Tony. Say hello, Tony.
Hello.
Hey man. So we have an interesting idea in mind for the format of this Newby Tuesdays. It's not exactly going to be like a project like a lot of the previous ones have. Um, what I'm thinking, and you all can tell me if this works, this format works or not, is essentially I've created this repo with lots of different exercises and descriptions of these different things. And me and Tony are going to kind of walk through it together. So I'm going to give like a quick lesson on what the thing is, and then Tony is going to attempt the exercises. I'm there to help, but hopefully he'll ask questions. And if you're not watching this as the live stream, you could rewatch this video, pull down this repo, and kind of follow along at the same time. So let us know if it works, if it doesn't work. But as I mentioned in the description, there is a link to this repo where you can see all the exercises and everything that we're going to do. Hey, James, thanks. Appreciate that. Dusan, welcome to the stream. Shalom, welcome to the stream. It's going to be fun.
Wait, is it your birthday today?
It was yesterday, Tony. You didn't tell me happy
Oh,
birthday.
happy birthday.
Thanks, man.
I didn't know.
No, it's all good. No, I had a good time. Yeah, I took a break from streaming. I went and saw Tycho at Red Rocks.
Nice.
Yeah, it was a good time. Actually, which I made this thing. So Tycho, he has like it's like ambient rock, intelligent dance music. Some of it's electronic.
It's like Boards of Canada with a band.
But he has lots of visuals, and so last night I got inspired and I decided to make this, which is from one of his albums. But I made that with P5JS. It kind of got me inspired.
I need you to make me some things.
But it kind of got me inspired to like make different visualizations like that with P5. But okay, let's get into this. So the idea is I've broken this down into pretty much 6 different sections. The first one is just talking about first class functions. So before we really even get into map, filter, and reduce, we're going to start at the most basics and talk about like what is it that allows JavaScript to do these things. Then we'll identify, it doesn't really have any exercises, but we'll talk about like where have you seen higher order functions before. And then we'll talk about for each. So if you cannot rewrite a for loop as a for each, then you need to start there before even attempting map, filter, or reduce. We'll talk about a pattern, and then we'll kind of get into map, filter, and reduce. I don't know if we'll have time to get to all of these things, but we'll see what happens. All right, Tony, are you ready?
I think so.
Okay. All right, let's.
I like how in the beginning you said Tony's going to attempt to do these, not that he's going to do them.
Well, I mean, he's giving it give it his best shot. The old college try, is that what it is? Cool. And actually, I don't know. Can I zoom in? I guess I can't. It should be good enough. Okay, Tony. First thing we're talking about is first class functions. So, in JavaScript. JavaScript is a programming language that has first-class functions. So there are a lot of different programming languages out there, and not all of them behave this way. And if you're only familiar with JavaScript, you might be like, well, of course, that's how it works. But I kind of wanted to take a step back so we can talk about this. But a programming language is said to have first-class functions when functions in that language are treated like any other variable. For example, in such a language, a function can be passed as an argument to other functions and can be returned by another function and can be assigned as a value to a variable. So an example of that is like assigning a function to a variable. And you might have seen this before. I am using fat arrow syntax here. The same thing would work with like regular function syntax. But basically, I have this variable called what time is it? Actually, I'll just show in the README. I can make it a little bit bigger. So I have a variable called what time is it, and I am assigning this function into that variable. And then after I've done that, I can actually invoke that variable because it has a function inside of it. You can also pass functions as arguments. So say, for example, this simple little function that just returns the string hello, and then greeting is a function that takes in two parameters, one of them being a function, the other one a string, and we're just going to log to the console the first function invoked concatenated with the other parameter that was passed in. And to see that in action, you would actually pass in say hello to the function and JavaScript, and then inside of the function, you invoke the argument that got passed in. Right? So Tony, have you seen this before, like the idea of storing a function in a variable?
Yeah, so like I was mentioning to you before we started the stream, I was messing around with Unity, and so sometimes you'll have functions within other functions. So I might have a function, for example, that if that first is an event where something collides with it, another function will run as a result of that event.
And so are you using C# for that, or?
Yeah, that's C#.
Yeah, so I think in C# they might be called lambdas. They're slightly different than like class methods, but you can pass them around as values. Like you could pass a function into another function and then call it. Hey, Emmy, welcome to the stream. James asked a question in the chat. Are all first-class functions also pure functions? And the answer to that is no. So like your functions can do literally anything they want. They can mutate global state. The idea of a pure function is a function that doesn't mutate any state outside of it. It takes in parameters and then returns some value, and it will always return the same value given that same input. But these functions, you can really make them do anything. Okay, and so have you seen something like this before, Tony? So this is a little interesting because you'll notice when we're invoking greeting, and really this should probably be like const greeting, but we're invoking greeting. The first parameter, say hello, is literally this function. Second parameter is a string. And then inside of greeting, we're actually invoking the thing that got passed in and adding a string onto the bit. Have you seen something like this before?
Yes.
Does it look foreign at all to you, or?
No, it doesn't look foreign. I think one of the things that'll get confusing to me sometimes is when you have, for example, the syntax on like line 26. I might read hello function not necessarily as a function, but as like a weird variable. So like if I would be seeing this on, say, like some sort of like W3 schools kind of thing, that might confuse me.
Yeah, and so I am using somewhat of a confusing syntax because this could also be written like this. So like you could actually have this as a function instead of a fat arrow. Like these two things, like there are some differences, but for the most part, you can think of them as kind of the same thing. But what you mentioned, like, yes, this actually, we're expecting that to be a function, the thing that gets passed in, because we are going to invoke it. Okay. And then the things can get even weirder. So a function that returns another function. So say hello is a function, but it itself returns a function that logs hello to the console. So we in seeing this, you might think about like, how can you actually invoke how can you invoke this? How can you invoke the inner function? Do you have any thoughts, Tony? Like, let's say like write some code right here. Like, what code would I have to write if I wanted to invoke this function?
If you wanted to call the hello,
inner,
like basically if you wanted to say hello.
Yeah, if I wanted to, so I ultimately want it to log hello. So like, how can we get to it? I have some answers down below, but and I guess you don't have to write any code, but do you have any ideas? Like, how might we go about this?
I guess I would just call say hello and invoke it.
Okay, so call say hello like that.
Yes.
And what will this do?
That should basically result in the rest of the function running.
It does, but notice it returns the function. It doesn't actually invoke a function. So by calling this,
so do we have to?
Yes. Complete your thought.
So do we have to call something as an argument within that function, like as a parameter?
Not quite. I'm about to show it, but so there's basically two ways we could do it. The first way is to like store this in a variable. So like let's say inner function equals say hello, because this will invoke this function, which returns this function. So now this function is stored inside of the in this inner function variable. And then if I did inner function invoked, now this is actually invoking this function here. And this is where hello would be logged. Am I blowing your mind?
Yeah, a little bit, a little bit, yeah.
Okay, cool. So like, but let's kind of break this down. So two different ways to do it. The first one is store the return value in a variable and invoke it. So say hello returns a function. So we're actually storing this function inside of this variable. Now that the function's inside of there, we can invoke it. Okay, so that's kind of what I just showed. But you could even do something trickier. You could use this weird syntax because the return of this invocation is a function, and functions can be invoked with parentheses, so now you have double parentheses on there.
And that weirdly makes more sense to me than line 49. Like,
okay.
I would have actually put parentheses inside the parentheses, so it's like double layered.
Something like that.
Like,
yeah.
Yeah. Like that would have been my thought because it's embedded within itself.
Yeah, but you have to think about it like return value. So that returns a function, and that can invoke it. There is some chats. Let's see. So David Smith had the answer. So like invoke say hello twice. We've got inception and funception. And a question in the chat from Eternal Mist, is that a closure? It is. So let's take a quick break. So let's take a stretch. Are you drinking any beverage at home, Tony?
No, I think when I get off, I'm gonna probably make some Earl Grey tea.
Cool. But from Eternal Mist asked if this is a closure. This is a closure because this outer function closes over this inner function. Now we're not using like a benefit of a closure would be able to reuse some variable that's defined out here inside of here. We're not doing that right now, but still technically this creates a closure. It's a function that's wrapping an inner function. Okay, that was fun. I don't really have any exercises. Do I have any exercises for this? Actually, I do. Yes. So we're gonna try some things, Tony. They're gonna be interesting. But if you are following along with this repo, I have some links out to MDN and Wikipedia that talk more about first-class functions. And all of these things just get easier the more you use them. I'll even like for me, even when I first started using JavaScript, I came from a C# background, so like functions as values didn't make that much sense to me, but now like I use them all the time. Any thoughts or questions on this before we try some exercises, Tony?
No, I think this is making some of the more complicated functions that I've seen, where it's like I'm trying to do some sort of crazy API calls and manipulation. This is starting to make them make more sense.
Okay, cool. All right, let's try an exercise. So the first one, I would like you to define a function called getName that returns your name as a string. This is not a trick question. You can just do it exactly as it says. So define a function called getName, and it returns your name as a string. Do you have control?
Okay, so yeah, all right. So I'm just gonna define or talk my way through it. So we're gonna call a function, name it, or define a function rather. Give it a body.
Okay.
And I guess we're gonna have to give name. Can I do const like within the function?
Yeah, definitely.
Or would it be okay? But yeah, so const name equals Tony, or do single quotes to make better CJ syntax.
There you go.
And then console.log name.
Okay, so we're close. The main thing is though, I want you to return name, not log it to the console.
Okay, all right. So, whoops, kept thinking. Right. So return name.
Awesome. Cool. So we got a basic function called getName. It returns Tony's name as a string. I'll show this kind of written how I had it in the examples. So you could say like getName is an anonymous function that then returns Tony, or you could still define a variable. But these two essentially are creating a function that returns the name.
Yeah, I need to start making my functions look like the bottom because it looks so much cleaner.
And there are some caveats to this, like the function. And actually, I think I kind of want to do a video or an episode on this. Like these functions are accessible anywhere in your document. Functions defined like this can only be called below this line. But as long as you're doing that, then it should still work. Okay, let me just catch up in the chat real quick. So, is the stream lagging for anyone else? Eternal Mist said, if so, I might have to do some like restart or something. I do have green in OBS, so let me know if anything is going on. Briggs asks what kind of work I do. So I was a teacher of full stack JavaScript for about 2.5 years. I left that job about a month and a half ago, decided to start streaming, and right now I don't really work anywhere, but pretty soon I'm going to start applying to be a developer somewhere. Yes, and we have some one-liner. So one-liner suggestions. So you could say get name, and I think this is why I do need to do like almost an entire episode on fat arrow functions. So this is how I had it written. Return like this. However, if a fat arrow just does a simple return statement, you can remove the curly braces, and this does the same thing. So this is a function that just returns the string Tony. Are you still there, Tony?
Okay.
Okay.
Yeah,
Cool.
it's just like because you're able to explain like that's how it does it. Like you're almost like taking away the pieces the way like I would have done it above. It makes more sense. But like if I saw that on its own, I'd be like, what is happening here?
Yeah, this is a function that returns Tony. Okay, let's keep moving. So, all right, we got a basic function. It's called getName. It returns Tony's name. Awesome. All right, now we're going to get a little bit trickier. So let's kind of take this one step at a time, but I want you to define a function called greet that takes in 2 parameters, getName, fn, and greeting. So just do that right now. So a function called greet takes in 2 parameters. Yeah, and James in the chat is asking, the arrow function is only ES6? Yeah, so fat arrow functions were introduced in ES 2015. And so yeah, you can't use them before ES5. Okay, so Tony, let's name them what we have there. So name it getName, fn, and greeting as the 2 parameters. So the first one.
Okay.
Yeah, and you don't have to do this, but it's really just for clarity. Cool. And then the second one should be greeting. Okay, so the function should log some greeting, comma, your name here. So let's think about this. So first, how can you just log the greeting?
Or you could do a console log or a return.
So we just want to log it. We don't want to return anything. So yeah, just try logging greeting. Okay. And then after that, we want to put your name there. So we haven't called your function yet, but if I told you getName function is a function that returns your name, how would you call that function right there? Let's. But actually, you don't actually need to pass anything in. Because basically what we're saying is, okay, we're going to call this function with a function and a greeting. We're going to log out the greeting followed by the return value of getName fn. So now if we actually try to invoke your function. So let's call greet. Pass in your getName function because you defined that up there. So you can just put that as the first parameter. Okay, and then comma, and then as a string, some greeting. Hello, goodbye, farewell. Yeah. Hello, peeps. Cool. And actually, let's run this code now. So we've got this function, it returns the string Tony. We've got this function, it takes in a function and a greeting, and then just logs the greeting with the function that it took in invoked. Cool. And now we're going to call that function with this function and the greeting hello peeps. Okay, let's run the code. We are in, I think 01? No, 00. So if I do node exercise.js, hello peeps, Tony. Cool. Call it again, but with some other greeting. Yeah, and in the chat, Amazon is showing how we can do this with a fat arrow and like with template literals. Okay, so let's try it. Hello, this is Tony. Cool. Thanks, Andrew. Appreciate it. Okay, so how weird is this, Tony? Like, do you kind of get what's happening here? Like, for like, I think the biggest part here of higher order functions is the fact that we're passing this function in to this function. So yeah, what's on your mind?
I think, yeah, the weirdest thing for me is the idea that the function that we're calling is pulling up another variable, and I don't have to worry about that variable because the function's already getting it. That makes sense?
You
like
mean
basically that's kind of so like we're yeah, so like when I was gonna call get name function, like I felt like I needed to say like the name within that as like an argument for the function. Like that would be my thinking.
Okay.
But
we could, yeah,
itself, like the function.
Yeah, the function itself has the name. So like we actually could rewrite it to take in the name and then log that name. That would be even more interesting. I do want to show what Amazon did in the chat. So what he did was, or she, sorry, defined a function called greet. So greet is a function that takes in the get name function and the greeting. And then we can use that like single line syntax to do like a console log. And instead of passing in multiple parameters, you could use a template string. So you could say grab the greeting followed by, yeah, so grab the greeting followed by the get name function invoked. So this will essentially do the same thing as this. And let's just try it real quick. Yeah, still works.
So when you do the template like that, you don't, and because it's in the console log, it already recognizes that space between that first closing bracket.
Yeah, so the way template literals work is you can put anything you want inside of here, but anytime it sees $curlies, it's going to evaluate that expression. So this expression is going to be the greeting, and then this expression is going to actually call the function. But yeah, you can put anything else you want before or after these curlies, and it will essentially does string concatenation for you. So it like takes this string, adds it to the result of that as a string. It's super useful to not have to like concatenate a bunch of strings together.
Right, and that's like something as like whenever I would do like really basic exercises on like free code camp or like code wars, like my functions look really gross because there's a lot of like accounting for like spaces and commas and stuff.
Yeah, and you're like concatenating all the strings together.
Yeah, so it's like, like
yeah, and actually let's show this while we're talking about it without a template literal. So if I wanted to do this with just strings, I could say greeting plus a string with a space in it plus the get name function, like that. So these two lines are equivalent. The first one uses template literals, the second one just uses string concatenation. Cool. All right, let's keep moving. We got lots to do. Go ahead and say something if you got it, Tony.
I was just gonna say, yeah, that first one, the first way it's done is way more appealing, knowing that that's an option.
Yeah, it looks nice. And if you want to research this, they are called template literals. Um, I'm not the biggest fan of the docs on MVN for template literals, but I'm sure there's tons of blog posts out there that talk about like different ways to use them. Cool. And Eternal Mist says, is that string interpolation? I think we might use the term expression interpolation. Yes. So I think that the fact that we're invoking this function inside of here is it's interpolating the value. Okay. All right. Now this gets fun, Tony. If you can figure this out, I'll send you a gift of some kind. Okay. Define a function called makeAdder that takes in one parameter. Any valid number. Okay. MakeAdder should return a function that takes in one parameter, other number. Here, let me pull up the examples that I have in the README, so you can see functions that return other functions. Like that's a function that returns a function. So I want you to return a function that takes in the parameter other number. All right, that is my break timer. Let's take a quick stretch, hands off the keyboard. Okay, you have like a straight equal sign. Let me get rid of that for you. Okay, so this second function should take in a parameter called other number. What are you thinking, Tony?
So I'm thinking it should return something.
Right,
and...
but we do need a parameter. So you're missing the parameter. I'll give you a hint. The parameters go right there. This function needs a parameter called other underscore number.
Okay, so that's
where the
other
parameters
number.
are.
Okay.
Okay, and now line 32 should return the sum of those two numbers. Okay, we've got it. This looks super weird, but now let's see the powers of doing this. And this is actually a functional programming concept called currying, but you don't got to worry about that. Let's make it happen. On this line of code, I want you to use your makeAdder function to create a function that adds 10 to a number. So to give you a hint, like create a variable called like 10 adder or something like that. You'll have to start it off with a letter.
A letter being
like you can't do 10 adder. You'd have to say like the letter T or something like that.
Oh, okay.
So create a variable called like 10 adder and set that equal to some invocation of the makeAdder function that would add 10 to a number. Okay. That is literally all we have to do. Now, invoke your function several times with different numbers and log the result. So this is what I was saying. You can't say 1 0. You have to do like 10 adder like that. Okay. Now let's do a console log. Let's invoke 10 adder and then pass in some number. Okay, what do you expect that to log, Tony?
That should be 12.
Okay, and do it again with some other number. So Eternal Mist in the chat is asking what I think my break timer app is called. It's called Timeout by Deja. If you're on, so that's for Mac. If you're on Windows, there's an app called iLeo. Okay, Tony. You've done it. I don't know if you understand what you've done, but let's see what happens here.
So we should get 12 and 30.
Yeah. Okay, but and so someone earlier asked about a closure. This is a closure because after we create this first function, we're getting back this function, but now it remembers what number was. So like each of these invocations remembered that number was 10. So that was the closure for the function that got returned. Awesome. Okay, so make another adder, call it like 5 adder or 10 or 20 adder or something like that. Cool. Let me help you out. That should be a const. All right, and then invoke it a couple times.
So that should be 8, and then we'll do it again. 5 adder, and this should be 10.
Yeah, definitely. Let's try it out. Boom, 8 and 10. Okay. So this is a closure. This is also currying. This is a currying function. But in this case, it makes it like super useful, right? Because you create this function once, and now you can use it over and over again with any other number, and it's always going to add 5 to it, or this one's always going to add 10 to it. Okay. Can you tell me? I don't know if we talked about it enough, but why is this a higher order function, Tony?
This is a higher order function because I can call the other function as a variable than another function.
So actually, do I talk about higher order functions first? No, actually, I don't even talk about how you identify a higher order function until the next section. But this is a higher order function because it returns a function. And
okay, so
yeah, and this is a higher order function because it takes in a function as an argument or as a parameter. Those are the two different ways to identify a higher order function. Cool. Yeah, and so Amazon is also showing the like the one-liner syntax. So again, this is going from the function syntax to just being fat arrows. So you can say make adder. That is a function that then returns so this function takes in our first number, and then this returns a function that returns other number plus number. And
so is in this instance, like fat arrow just means return.
So that's the idea with an arrow function. If it has only one line of code, that's going to be the return value of that function. So what this is saying is this function takes in a number and returns this function. And this should work in exactly the same way. It's just less verbose syntax. Yeah. What do you think about that, Tony?
I think you should do like a whole video on just like taking code and just like doing like one line functions. I think that's really interesting.
Turning it into fat arrows, definitely. Yeah, no, thanks for Amazon for that tip. Okay, so let's move on. This is really just driving home the concept of first-class functions, like the fact that we can pass functions into functions, we can return functions from functions, and that allows you to do some pretty interesting things in JavaScript. Okay, any last questions or comments about these things before we move on to identifying higher order functions?
I think I'm good.
Okay, cool. All right. Now moving on to section 01, identify higher order functions. Does that work? Cool. Okay. So I kind of mentioned this, but to really just drive it home, higher order functions are functions that take in a function as an argument or return a function as a result. And so we saw examples of both those things in the last section. So here's some examples of higher order functions that you have probably used in your everyday JavaScript life. So for instance, add event listener in the DOM. It takes in a function as the second argument. And that function is not invoked immediately, right? You're just giving it the value, the function itself, and then later on when that event happens, the DOM will call that function for you, right? So this is an example of adding a click listener to the body. You're passing in this function, and it doesn't get called immediately. You're just saying, here's this function, and later on, when click happens, please invoke this function. And you often see it like defined in line like that, but you could technically store it in a variable. You could say your function here is called body click, and then the second parameter you just pass in that variable rather than just defining the function in line. And I'm really just showing this because you should be able to identify that add event listener is a higher order function because it takes in a function as a parameter. Yeah, and Ross is mentioning I can do Markdown preview. The only thing I don't like is the font is small and I can't seem to zoom in on it. Let's see. Zoom in. Oh, okay. Well, that's zooming the whole UI. I think that's okay though. Cool. All right. And here's another place where you may have seen a higher order function. A call to like fetch or jQuery Ajax or Axios or something like that. The .then of a promise is a higher order function. The function passed to it will be called when the promise is resolved. So for instance, if we're making a request out to the Reddit API, we'll do a .then, and then we're passing this function in, which will get invoked whenever the result or the response comes back from the API request. And then this function will be invoked whenever this function it has resolved and is done parsing it as JSON. So .then of a promise is a higher order function. Add event listener is a higher order function. And this same example can be written with variable names, just kind of like I showed before. So like you could create a function. Oh no. You could create a function called response.json, set that equal to that function. Create a function called log result, set it equal to that second function, and then that would kind of clean up your call to fetch. You could say fetch, and then response.json, and then log result. Cool. Questions, thoughts, comments about this, Tony?
I think it's cool that you kind of included that, like, basically, like, the second you start using JavaScript within like a web context, you're already using these functions.
Yeah, definitely. And like early on, it's hard to really even figure out what these things are because you're just like getting used to programming in general. But the main point of this section was like, look, you used this stuff before, and now when we start talking about ForEach and map, filter, and reduce, it's the similar idea. You're giving it a function that's not going to be called right now. It's going to be called whenever the thing you're giving it to decides when to call that function. So question to you, Tony, is add event listener a higher order function, and why?
Yes, it's a higher order function because it's taking another function, or it's taking another function as a variable, like whatever event that we want to happen that it's listening for has to be a function.
Yeah, and so it takes a function as an argument, so that's how we know it is a higher order function. Yeah, and so Amazon is mentioning async await. So if we use async await, then we're actually not using higher order functions. But it's good to mention. I'll just kind of show that how you would write this same thing with async await. Let's do it here. So for one, you would need this to be inside of an async function to be able to use it. So maybe you like pass in the URL and you want to do this, and you give it the URL. But the way await and async works is instead of having to do a .then, you can actually store these things in a variable. So you could say like const response equals await fetch, and then now this will actually do the .then for us. And then we could also say const result equals await response.json, and then we instantly have access to the result. Now, under the hood, this is doing the same thing as these .thens. We're just not using any higher order functions here. Async await is new. I think it was introduced in ES 2017, maybe 2018. But if you learn this, then you don't technically have to use this promises or higher order functions like that. These are still using promises under the hood. I digress. Question in the chat: are higher order functions always callbacks? You could think of it like that. I think you might use a different term, like it's either going to be callback or handler. There's some other terms thrown around, but anytime you're passing a function to some other function invocation, that is a higher order function. I think I've done this with you, Tony, this async await thing, right?
Yeah, I think so. We've done a lot of API stuff.
Yeah, and so these two are like functionally equivalent. This one just uses async await. Cool. All right, moving right along. We don't have any exercises for that, but I just wanted you to be able to talk about a higher order function. So, Tony, in your own words, what is a higher order function?
A higher order function is essentially a function that can be stored as a variable or takes in another function.
You missed the second one. So it is a function that takes in a function. The other one is a function that returns a function, not that it can be stored in a variable. Let's see. Or return a function as a result. So like our make adder function that we created, that was an example of a higher order function because it returned a function. You mentioned storing functions and variables. This is just an aspect of being a first class functions, but this is not higher order functions. Does that help?
Okay.
Cool. All right, let's keep moving. All right, now on to ForEach. Now, ForEach is a higher order method, and if you're totally new to like map, filter, reduce, I recommend doing things with ForEach first, because once you get used to the fact that you're passing in a function that's going to get invoked multiple times, it's going to be a little bit easier to wrap your mind around like what's happening with map or what's happening with filter or reduce. Okay, so Tony, have you seen ForEach before? I think maybe we've used it in some of the apps we've built.
Yeah. Well, we use like for stuff like doing like FizzBuzz type things before.
Okay. So the ForEach method on the array prototype executes a provided function once for each element in the calling array. For loops can often be replaced with a ForEach, and ForEach is a higher order function. So, for example, if I had this array of numbers and I wanted to log each number in that array, I could write a for loop. Goes from 0 to the end of the array. We'll store each number in a variable and then log that number out to the screen. Pretty simple stuff. But you can do this exact same thing with ForEach. So ForEach accepts a function that will take a parameter that's going to be each value inside of the array. It's my break timer. Let's take a quick stretch. So ForEach takes in a function that takes a parameter that is or will be each value inside of the function, and then you can do something with that parameter. So this can just be rewritten in this way. We say numbers.forEach, we get access to the number, and then we just log out the number.
With the ForEach though, like you don't have like any sort of enumerator though.
And so I'll show in a second, you actually do. So you do get a second parameter that's the index if you need access to it. And then you also get access to the array. But that you really only can add those in if you want or if you need to use them. So Amazon is asking like why I keep writing my functions like this. Because it could be written with this, like without the curlies. I'm mainly doing this because this is for beginners. And if you've never seen a fat arrow function before, that can get really hard to get used to, like not seeing the curly braces. But yeah, you're absolutely right. Like anywhere where I have a fat arrow function that only has a single line of code, it can be written like this. Definitely.
I kind of view fat arrows almost like the mustaches of the programming world. It's like a pretentious thing.
Some people actually don't like fat arrows. They think they're less descriptive than like the function keyword. The biggest thing that they're mainly used for is like lexical scoping. We're not going to talk about that in this episode, but in Amazon, it's not my preference. Like I personally, if a fat arrow is like a one-liner, I'll write it without the curlies. It's really just so that beginners can see like this is a function body. I don't know. How do you feel about it, Tony? Like, if you were, does this look more weird to you than the one with the curlies? Or like,
Um, it, it looks less weird now that you've explained it, but yeah, like I would definitely like if I was looking at somebody's code, not knowing that, I would be a little confused as to what was actually happening.
yeah, I'll keep it in here. Can also write it this way. Yeah, it's mainly just for readability. William says he doesn't like fat arrows. Yeah, they're cool. I don't know. That's not what this is about, though. But, Tony, you see the comparison between these two, right? Like, instead of writing out the for loop, you can actually just say sum array.forEach. You get access to each element. And then you would ask about... go ahead.
Well, I was gonna say like the only difference between the for each is like we have to declare our enumerator or other parameters like within that same parentheses,
Right,
right?
and yeah, and so the for each callback will get called with the current element, the index that it is in the array, and then the array itself. So if you did need access to the index, you could add that second parameter in there. It is optional though, and often when you're using a for each, you don't necessarily need access to the index because it's already iterating for you. There are some cases where you might, like if you're like shifting the array or something like that. But yeah, you get the element in the array, its index in the array, and then the array itself if you need to operate on it. Hey Bob, welcome to the stream. Okay. All right, Tony, let's move into some exercises. These are going to be pretty basic. It's basically going to be taking a for loop that's written like this and then turning it into a for each instead. So before we jump into that, like what are some things you notice about this? Like what are maybe some steps we'd have to take to convert this for loop into a for each?
I guess well, like are you asking like what I need to know for a for each to make it into a I'm
I
sorry,
mean, kind of like, yeah, so
rephrase the
like,
question.
more of like, what are the steps to take? So like, okay, I have this for loop, it's written this way, but I want to rewrite it as a for each over an array. So like, what are some of the things in the for loop that I'm going to need to use or reuse? And like, how would I convert it?
Well, first off, you're gonna need whatever your variable name is, um, and whatever like parameter you're passing through it.
Yes. Okay, so let's try some exercises. Um, let's see. Cool. All right. Convert the following for loop to a for each call on the array. So we have this array of flavors, and we want to log out I like given flavor cake. So I want you to convert this into a for each. Give it a try. Yeah, and Amazon in the
So
chat.
first,
Just a second. So Amazon in the chat is saying that for loops are faster and you can't break or return. That's absolutely true. I'm really just showing them now to kind of get used to the idea of passing in a function to iterate over an array. But the very last section, I talk about some other higher order methods that will allow you to like break out early if you need to, because you typically can't do that with like a map, filter, or reduce or for each. They're always going to iterate over the whole array. Okay, so
can we pop out the other example of for each
Yeah.
so I could just see? Yeah.
Definitely. So the idea is, and this comes in where we're saying that the for each method is on the array prototype. So what that means is any array, you'll say array dot for each. So you can see that example there.
Okay, so I've got the thing backwards. Do flavors.
Flavors? Yeah, and if you can, talk me through what you're doing and what you're thinking.
Okay, so I'm doing flavors dot for each, and then I guess I'd be calling. Would it make sense to use number of flavors here? Like if you say number.
No. So.
Or would I call?
Yeah, you could call it flavor. Yeah. So the idea is this first parameter, you can name it whatever you want. And typically you want to name it like something that makes sense for what you're coding up.
I'm having a little error here.
Oh, just a second. Yeah, there's. Oh man, I think my VS Code just froze. Okay, cool. Just a second. Wait, stop moving the mouse. Okay. All right, give it a try.
So basically, we have a singular version of our flavors.
Mm-hmm. That's going to be each flavor in the array.
Right. So we're going to be calling it with this. Actually, missed a step here.
Yeah, so you need to, well, technically, so here's another thing about fat arrow functions. Let me show you real quick. If a fat arrow only takes in one parameter, you can actually leave off those parentheses, but just add them for now, just for clarity.
Okay, and then put our other,
Mm-hmm.
and then close that. And so we're going to console.log, and we're going to use our little friend here. Or the backticks,
Okay.
rather.
Okay, Tony's getting a little.
So we're going to
advanced.
say I like cache flavor plus. Oh, no, we don't even need that. Just need to close that. And cake.
All right. Oh no! My computer died. I'll be right back. That is very unfortunate. I totally forgot to plug in my computer. Just give me a second. I'll boot right back up. And those of you watching, so it's a good thing I do actually have a separate streaming computer that is plugged in. So I'll just need to reboot. We'll get back on the call. We'll get going. But those of you that have been watching, do you like this format? Is this something that works for you? Are you following along to the repo? Oh no. I knew I needed to plug in my computer too. Might take a few seconds. It's got to charge up a little bit. We'll give it a second. But I have something interesting. Oh, okay, awesome. We're back in business. But I will show what I was about to show. So a friend gave me a green screen cape for my birthday yesterday, so I can be a floating head. Let me show that real quick. Oh. Cool. Oh, and James has a suggestion. I am a floating head. James wanted to throw out an idea. The next time I do Code Wars, which will be tomorrow night, I am going to do a Code Wars stream tomorrow night. Floating hands. Throw out the ones I'm going to do in advance so you guys can give them a try. Definitely about that. I haven't been getting any suggestions for ones to do, so probably tonight I'll go through and add the ones that I want to add, and then I'll post them probably in the description so you can try them beforehand. But floating head.
Can you hear me?
Wait, are you still there, Tony?
Yeah, I'm here.
Oh, cool. And I think I just need to restart the screen share real quick.
Yeah. Well, was I on the right page? I like got cut off right as I was doing some stuff.
Oh yeah, you did it. You did it, Tony. And actually, if you were
Oh,
talking,
nice.
then I couldn't hear you, and the stream could hear you. Let's copy that.
I just need is the Zoom thing still on?
I think I might have
Or
created.
I think you.
I created a new one, so just give me a second. I'll send you the link. I can't believe I forgot to plug in my computer. There you go. That's a new Zoom link. Let me know when you're connected. All right. And I will turn my screen back on. Crisis averted. All right. You still there, Tony?
I'm here.
Okay, cool. So, talk me through what you did and why you think it's right.
It's right because I did it. First of all, no. So we called the flavors, and then we basically said for each of these flavors, they are a flavor. And that's how we're essentially dividing the array up. And then we're saying that we're going to console log a string that's I like, and we're inserting our flavor variable, whatever that may be. And I guess we could, if we called for each, we would call the index of that. We would say like flavor 0 would be chocolate, 1, etc.
If you wanted to access it that way. Yeah. And the main thing to think about is like this is just like a generic function that takes in a flavor, but under the hood, it is literally going to invoke this function for every single thing inside of the flavors array. And that's what's happening under the hood. Like it's calling this function with flavors bracket 0 with flavors bracket 1. Let's run the code, make sure it works. So I'm going to comment these things out, and let's see what we get. We're going to go into the O2 for each, and then run the exercises. There you go. Chocolate, ginger, carrot, coffee,
nice.
walnut, banana.
It's a lot of cake.
Yeah. And again, we can write this as kind of like a one-liner. We could do for each flavor, log it out. Cool. All right, Tony, on to the next one. So this is where I actually want you to access the index. So here. So notice this for loop is iterating over numbers and then saying the number is at index I. So go ahead and write it out as if you were to just, like if you wanted to log every number in the array, but then we can talk about how you get access to that index if you forgot. And so you can follow your previous example. Are you there? Tony?
Yeah, I don't know if I have screen share though.
Oh, you know what? You don't. Sorry. There you go.
Okay, cool. So we're gonna do it like we did before. Second reverse, same as the first, but not. All right. So, and I think you were saying because it's one thing, we don't have to do that.
Mm-hmm.
Do our favorite hipster thing with the thing. So, and we would console dot log. So I guess this is where I want to do it the same way as before, but you're going to tell me I'm wrong.
Try it.
Somehow. So number plus, or not really plus, but plus in a sense. Number, so I don't know if I want to use this because of the way we could call the number.
Well, that should be totally fine because this will give us the current number. The only thing that we need to worry about is like how do we get the index.
Okay, so yeah, so let me just finish up index. Okay, so
And then how do we get it? So
and this
I'll show you in the README we talked about if you wanted to get access to the index, you could pass it as another parameter.
oh,
Okay.
so we need a
Yeah.
thing there.
Yeah. So give it a try. But now that you have two parameters, you actually do need
But
to wrap it in
no,
parentheses.
yeah. So we're gonna highlight that and
Yeah.
do the thing. And then we would just say, actually, nope. And we would just do the thing again, and we call the index.
Yes. All right. Let's give it a try. Let's comment that out. The number 2 is at index 0. The number 4 is at index 1, etc. Good job, Tony. Yeah, and the main thing with this exercise was like getting access to that index. And so if you want it, it's the second parameter. Cool. Let's do these. All right, this is a weird one. And we'll talk about later like how you might do this not with a for each loop. But here's the example. So we have this array of numbers, and then inside of the for loop, we're overwriting each number with that number times 2. So if you want to see what this logs, like right now, we start with 2, 4, 6, 8, 10. After we run this, we get 4, 8, 12, 16, 20. So it uses the same array and then just overwrites it with each value doubled. So give it a try. How might we do this? Are you still there, Tony? Like I see you doing it, but I don't hear you.
Yeah, I'm here.
Okay.
Yeah, I'm sorry.
No worries. But think out loud. So like, what are you thinking? What are you doing?
Okay, so we're gonna call our prototype thing. Why is it called that, by the way?
It's because the actual array object. So array. This is the built-in thing in JavaScript that actually gets created when you use these square brackets. And on its prototype, there is a function called ForEach, which means that any function you create has access to this ForEach. So we say that ForEach is defined on the prototype, meaning any instance of an array can use it. And map, filter, reduce, those are all defined on the prototype. And so they actually went in and said like, ForEach is a function that takes in, doesn't take in anything, and then it does the thing. Yeah, but that's basically what we mean. The built-in array has it on it so that any array that we create, we can use it.
Okay, all right. So we're gonna call a number, I think. So we're gonna call a number, do that, and we're going to console .log our number times.
We don't want to console log it. Notice that we're putting it back into the array.
Oh, okay. So yeah, so we're essentially changing the. Oh.
There you go.
There we go. Yeah. So we're essentially. No, come on. I'm just gonna delete this. Okay. So we're essentially creating a new array.
Well, not creating a new array. We're overwriting the existing array. That's right.
Overwrite. Okay. Yeah. That's fine.
Yeah. Okay. So we're saying take the current number at this index, multiply it by 2, and put it back into the array.
Okay. So we're going to say number. Actually, should have index if I'm going to do that.
Okay.
So we comma index, so number times index, or
So here's the thing, Tony. When we convert a for loop to a for each, you can pretty much just take what's inside of the for statement and put it in here. But now we need to convert this to what we have available to us. So we no longer have I. What do we have instead?
Now we just have the index.
Yeah, so let's use that instead. Cool. And then we could, right there, we could say even numbers bracket index, but we have access to number, which is that. So let's use that instead. Yes. Yes. And then we'll log this below there. I'm really, like I said, if we were doing this, we would probably use a map or something like that, and that would create a new array. I'm just showing different ways of using a for each loop. Okay, but we have this array. We use for each, and inside of it, we actually are overriding the array itself. So remember I said that for each takes one more parameter? You remember what that is?
Yeah.
What is it?
It's the array itself.
Okay, so let's bring that parameter in and then use the array itself instead of directly calling even numbers. Cool. Yeah, very cool. Okay, so that does it. Let's see if it works. Yeah, so now we still get those numbers doubled. All right, we're going to keep moving.
And now we get the CJ way of condensing it.
Yeah, and I guess I'll show real quick. So if you wanted to condense this, you could write it without the curlies in a single line, just like that. However, now that we're running that twice, it's going to be quadrupled, because this would run once, and then this runs again, which would double it again. Okay, I think this is the last one, and then we're going to move on to map. And we've been streaming about an hour, 8 minutes, so I think we're making good time. We may not make it to all of the exercises today, but yeah, we're making good progress. So I want you to log the name of each product to the page with a for each on products. So I want you to log the name of each product. You can do it right there. Using a for
Okay,
each.
so there was actually, I could have used this the other day when I was doing a code kata, because it was something basically trying to get the name.
Okay.
Okay, so products dot for each, and we're gonna say product, because that's all we really want. Going to say we want. Trying to think.
So we want to log the name of each product.
This feels very wrong, but
Well,
in my mind it
is very right. So you got it. Because this product is literally going to be each one of these objects. And each one of these objects has a property called name, so you can use dot notation.
Oh my god.
You did it, Tony! Okay, and then also...
I was doing it in my head, I was like, this makes sense, but it feels wrong.
No, it's totally right. And when we're using things like map and filter, like often you're doing map and filter over arrays of objects, so you actually need to access their properties. And then again, you can do it the shorter way too. Awesome! You're doing good, Tony. Doing good. All right. Let's get on to... Oh yeah, so I think I put way too much stuff in here. But before we get to map, I do want to talk about this thing called the accumulator pattern, because when you're doing map, filter, or reduce, you're typically following this pattern. So let's talk about it. I do want to zoom bigger, make it bigger. The thing is, I overwrote the built-in VS Code zoom to be font size zoom instead because that's how I'm used to it in Atom. But regardless, okay. The accumulator pattern. So a common programming pattern is to iterate over an array, accumulating a value as we go. So this pattern is commonly used to sum the numbers in an array, or to build a new array based on an existing array, or to build an object based on an array, or to build a string based on an array. Basically, you have some variable that you're accumulating as you go over the array. And so there are three parts to the accumulator pattern. First, you initialize an accumulator variable to some initial value. You then iterate over the array, and then inside of that iteration, you update the accumulator variable on each iteration. So let's see what this means with actual code. So let's say, for instance, we had this array of numbers, and we wanted to add all of them together. So first step of the accumulator pattern is define your variable called sum, and set it to some initial value. In this case, we start at 0 because if there were no numbers in the array, the sum would be 0, but we start there. And then we iterate over the array. Then, third part of the accumulator pattern is to update the accumulator based on the current value in the array. And so in this case, when we're doing a sum, we're taking number and adding it on to sum. And so on each iteration, sum is getting bigger and bigger with each value of the array. And then when the for loop is over, when the for loop is over, we have the total sum. So this pattern of initial value, iterate and update the accumulator, and then you have your final result. This is the accumulator pattern. Now this could be done with the ForEach. Typically when you're using a filter or a map, you're accumulating an array. Reduce can be accumulating to some other value, but this is what's really happening. You have some value and you're building it up. Thoughts, comments, questions about this, Tony?
No, I think,
Are you pretty clear on what's happening on this line of code? Like it's saying, yeah, do you know, what is that line of code doing?
basically you're saying the sum is plus equal the number, which it's getting the number, basically the number is coming from the index that it's at in the array, and you're adding that on to 0.
Well,
so it'd be like 1 plus 1, or actually 1 plus 0,
right,
and 2 plus 1.
Exactly. And so this is just another way to write, where are we at? Sum equals sum plus number. So take the current value of sum, add number to it, and then store it back in the sum variable. Okay, so that's like your basic accumulator pattern. Define a variable. You know what? I'm going to try to stop doing this. I'm just going to... I am just going to use my markdown. Okay, so define a variable, iterate, and then update the accumulator, and then you're done. This is another example of the accumulator pattern. So in this case, we're not accumulating a sum, we're accumulating a whole new array. So we have our numbers, we have this array that's empty called doubled numbers. Let's take a quick stretch. And this is the initial value of our accumulator, it's an empty array. And then we iterate over the array. But the thing that we're accumulating is new values into the array. So we're saying doubled numbers.push the current number times 2. So we're updating the accumulator by pushing a value into the array. And then at the end of all of this, Tony, can you tell me what will doubled numbers be?
Doubled numbers, like what the value would be?
Yeah, like what is inside that variable?
It's going to be everything doubled based on its array thing. So it would be 0 for the first one. 2 would be 2.
Well, notice
the second one would be...
Notice what we're pushing into the array. It's the current number multiplied by 2.
Oh, it's a okay, I kept thinking it was multiplied by... So it'd be number multiplied by 2. So it would be... first one would be... still 0. Second one would be 4.
Tony, what is 1 times 2?
I thought the number would be the. Is it not the array number?
No, so because notice we're using the index to actually grab the number out of the array itself.
Oh, okay. So it would be just like.
Just the number itself multiplied by 2.
Okay.
So what are the results? What's inside this array?
So it'd be 2, 4, 6, 8, 10.
Yeah, definitely. And really, this is just another example to show that like we are accumulating up into this array. All right, let's try some exercises. And I think initially, I just want you to rewrite these with a for each instead. So they're already solved for you. So like this is the same sum problem, but I want you to rewrite this with a for each instead of a for loop.
Okay, just a random thought. Do
Yeah.
you have any coding stickers yet?
You know what? I do, but they're not official. I need to do some work on them. But anybody watching live, first time ever seen on stream. Or do you have the stream up, Tony? Can you see? Oh.
Yeah.
The green screen is like cutting out the colors, but it's cool little flowers. They do have green stems, so you can't see them because of my green screen. And that's supposed to be JavaScript.
Oh, those are cool.
But I need to do some work on them because they're not quite the size that I want. I need to work on the font, but soon. Stickers are coming soon. Why did you ask? You want stickers?
Yeah, you were saying you were going to send me something. I'd really like a JavaScript plant sticker.
Definitely. All right, let's do this, Tony. Convert this for loop into a for each.
Okay, so first we're going to take our numbers 1 array. Or actually, yeah, so we're going to take that. We're going to say for each. I'm going to say number. And we're going to give it a little fat arrow. And I want to say we don't have to call sum here because sum's already a thing. Or
you don't have to redefine
right?
it.
Like
You don't have to
already
redefine it. Yeah, so you can leave this line of code here, but you do want to add the number to sum inside of the for each.
Okay, so we want number. Can't see. So we want number.
And I'll give you a hint, just like before. Like, you take whatever is inside of the for loop and just put it inside of the for each. But we don't need the first line because we already have access to the number because of the way for each works.
Okay, so we still need that array.
No.
The index, rather.
Tony.
No. Whoops.
No, you don't need the index either. Look, this is all I want you to do. Take this, put it in there. Done.
That's it?
That's it. So when we're converting from a for loop to a for each, you're not going to do anything that gets access to the value itself because the for each is already giving you access to that value. But whatever you were doing otherwise can just go inside of there. What do you think?
Okay. I kept thinking that was going to be like a lot harder than I guess it actually
was.
Not at all. I wanted it to be harder for some reason.
No, not at all. And so let's see what we get. No, actually, we are in 03 now. So now we get 15. So the sum of all of these numbers is 15. Cool. Let's keep moving. It's got more stuff to do. So let's do number 2. This is another interesting one because we're not like creating a sum. We are actually creating a new array. But remember what I told you about like what's inside the for loop. That's all that's going to go inside of the for each. So we have this array of things. We're creating a new array called copied things, and we're just pushing all of the things into the copied array. Things for each thing. copied things. There you go. That's all it takes, Tony. Good job. Let's watch the code happen. Sweet. And this might be an example of where we use a map. And we're actually going to be talking about that next, but this works in the same way. Thoughts, comments, questions about this one?
No, I think it's pretty straightforward.
He's getting it. Okay. Let's do... I think this is... Actually, we have a few more. Okay. So we are creating an array of doubled numbers. Is that the first thing we did? No, we're just doing sum. Okay. This one was actually in the example, but give it a try. So we're going to use a ForEach instead of a for loop. Done. You're getting good at this, Tony. Anything to say for yourself?
I don't think we need to open up our own agency.
And code all the things. And this is the last one. So this is a tricky one, but I swear to you, it's not a trick question. You can follow a very similar pattern. So like whatever is inside of the for loop is essentially what's going to be inside of the for each. Okay, and so what this is doing is we have an array of 10 numbers, and then we have an empty array called even numbers. Then we iterate over numbers, and if the current number is divisible by 2, we push it into the even numbers. Otherwise, we don't do anything. And then lastly, we will end up with an array of only the even numbers. So let's try to do this with a for each. Brett says you need some coding art and stickers soon, very soon. Like I said, I wanna figure out. I wanna get them right before I get people start buying them, because I don't wanna send crap.
So when we made like band stickers way back when, I feel like the prices have gone down so much since then.
Well, I'm using a service called Redbubble, and actually, I mean, you can't see my laptop, but I have tons of stickers on it. That I got from Redbubble. But the cool thing about them is they ship internationally, and they print your stickers on demand. So if somebody goes on their site and makes an order, they'll print just the stickers that they order. And I'm going to use that service because I do have a lot of international viewers that might want to buy some.
Right. Does that look...
You did it!
Right?
You did it.
Nice.
Yeah. So we're going to iterate over all the numbers. If that number is divisible by 2, push it into even numbers, and then done. So we should end up with 2, 4, 6, 8, 10. Why did that happen twice? Oh, because we also doubled these, which was 2, 4, 6, 8, 10. Cool. I think you're getting it, man. All right. I think, like, I don't want to... I did advertise this as being, like, map filter reduced, so I don't want to... anybody that did come to watch it, like, you didn't get what you want. We are going to do map, but I think we'll stop after that and then just continue this on either the next Newby Tuesday or on another Newby Tuesday. But Tony, do you still have it in you to do map?
Yeah, I think I got like one more
got one more
round of exercises before I bleed from the nose.
Okay. And this is I don't know, you're doing well, man. We're packing a lot.
That should be the Newbie Tuesdays sticker. Is like a cartoon of me just bleeding from my nose.
You're doing well, Tony. Okay. All right, so let's talk about map. And so, like, really all of the concepts that we've talked about build up to using something like map. So first-class functions, higher order functions, the accumulator pattern. Map kind of wraps that all into one, and you can kind of like basically do it on one line of code. It is less code, but let's talk about what it does. And for this, I will do the markdown preview. So the map method on the array prototype. So Tony, what does it mean to be on the array prototype?
To be on the array prototype like as you defined it earlier.
Yeah, what? Yeah, just say it back to me. What does it mean?
Basically, we can call methods to it. That makes sense.
I guess
I
the easiest way to say it is any array that we create has access to the map function, meaning we can call map on any array that we create.
Okay, so basically, if it's any sort of array, it has a so this could be any sort of JavaScript thing. If it's a prototype, it has access to these methods.
Yeah, so like substring is a prototype on the string object. Or if you think about any function that you can call from like a number or a string, that thing would have been defined on the prototype, meaning any instance of that thing has access to that. Okay.
Okay.
Let's keep moving. Okay. So the map method on the array prototype creates a new array with the results of calling a provided function on every element in the calling array. Map is a higher order function. So the call to map will return a new array. So the thing to think about is when you map over an array, you're getting back a brand new array. But this callback function that you put into it, the return value of the callback function will the return value used will appear in the new array. So as this diagram, for instance, says, okay, let's say you have an array with the values 1, 2, and 3. And then you have this function called double. It takes in a number and returns it times 2. So if we ran each of these numbers through the double function, we would get the values 2, 4, and 6. And basically, we could hand the double function to map, and it would give us back an array of 2, 4, and 6. Okay, let's see some examples. So we actually just did this one with the ForEach. So for instance, you have an array of numbers. You create a new variable called doubled numbers, and then you iterate over the numbers and then just push in number times 2 for to the doubled numbers array, right? This is doing what you might do with a map, but we're not using map. And you just did this. So there's that. But we could write the same code with a map instead. So notice we'll say, well, we have our numbers, and then we'll say doubled numbers equals numbers.map. And then this callback function will return the current number times 2. So ultimately what's happening is this function is going to get called on every value inside of the array, and whatever it returns will appear in the new array. And then to even like, go ahead.
I was gonna say, are we using let because we could change the values?
I mean, actually, yeah, these could be const because we're not overriding the variable declaration.
But if we would use let.
Yes, if you wanted to put something new in that variable, you'd use let, definitely. All right, break timer. And Amazon has some interesting code with like a ForEach bind. Yeah, and he's saying we need to teach call, apply, and bind. I think definitely in a future episode. Like I also want to do. I mean that would imply talking about this and just like how this works and what it means in different contexts. Definitely. Okay, Tony. So this is a map. Let's see that same map, but with a function defined externally. So let's say we defined our function out here called double, and then we say numbers.map. We give it that function reference, and then it gives us back an array of doubled numbers. So basically, we give it a function that it will call on every value in the array. Say what you got to say, Tony.
Oh, nothing. I'm sorry.
No worries, man. But isn't this beautiful? Just take a second. Like, yeah?
It's all shiny.
Cool.
And chrome.
And if you compare this with something like when it was written with the ForEach, like this is much more manual, right? We have to create the array. We have to push into the array. A map is doing all of that under the hood for us. So we just end up with a brand new array. And again, the map function, just like for each, it gets 3 parameters. So you get the value itself, you get the index, and then you get the array that it was called on. So if you wanted to access those things, you have access to them just like you do inside of for each. Cool. And the thing to think about is when to use map is when you want a new array of the same length with some operation performed on each value inside of the array. So map is always going to return a new array of the same length of the array that you're mapping over. Okay? Tony?
Okay.
You with me?
Okay.
All right. All right. Let's give it a try. All right. So we've got some exercises for map. This is an easy one because I kind of just showed the example, but and I can pull up the example if you need me to. But I want you to create a new array with these numbers doubled. So create a variable, call it like doubled numbers, and set it equal to numbers.map something.
Can I see the example again?
Yeah, definitely. And so, well, just go ahead and get started though. So you get a function and it takes in number. So you can start there. And give it a function body. Well, nope, the fat arrow. Nope, nope. Okay. Yeah. Okay, and then we'll give it the body.
All right.
All right, Tony. So, what is it that we want to do to each value inside of this array?
So we essentially want to age by 2.
Yes. So let's do that. Let's multiply the number by 2.
So we return number times 2.
Yeah, and that would actually do it. The important thing to note is that we're returning. So whatever is returned from this function is what will show up in the new array at that index. So let's log it out and make sure it happens. Doubled numbers. Let's comment this stuff out and clear. Let's go up one directory, go into map, and then run the exercises. Cool. So we doubled 1342 and 1337. All right. Easy enough. Let's move on to this one. Okay, so we have an array of all the days of the week, and I want you to create a new array with just the first 3 letters of each day. Okay, so what are you gonna call your variable? Oh yeah, Amazon in the chat.
We'll call it lazy days.
Lazy days. Okay. Too much info for a short amount of time. He needs some rest. I think so. So we are gonna call it after doing map. But yeah, you're being a trooper, Tony. I appreciate you.
Yeah, it's like doing this after the a day of like scrubbing cases and stuff, and it's just like, oh. Okay, so how am I doing this? All right. Okay, so I'm calling days again.
So we're gonna do days.map, and then this will be a function. What should you call each thing that gets passed into the function? Day. Yeah, totally. And then what do we want to return from here?
We want the first 3 index things from each thing.
Okay, so how much you do
The
that?
first 3 letters.
First 3 letters, yeah.
First 3 letters. Oh, sweet. Okay. We're gonna return the Jedi. Okay, and day.
So I'll give you a hint because that's not what this episode is about. There is a built-in method called Substring. And you can pass in where do you want to start, like what index do you want to start the substring, and then what index do you want to end the substring. So it takes in...
so it would go from 0 to 3. So would I call it 0 to 2? 0 to 2 rather. Does that look right?
Let's try it. Actually, I think it's non-inclusive, so you might actually want to do 0 to 3. But let's log the easy days. Yeah, so you actually do want to go to 3 because substring is non-inclusive of that last index. And if you want to know more about that, you can check out MDN for substring. Returns a part of the string between a start and end indexing. But you got it, Tony. Like we mapped over the array of full days and just returned the first 3 letters of each day, which resulted in a new array with the abbreviations. Cool. All right, this next one. So we have an array of people with a first name and a last name. And I want you to create a new array with a string that has the full name of each person. So it should just be first name space last name as a string. Go ahead. So let's call this full names because it is going to be an array.
Oh, okay.
Yeah.
What was the thing? Was it names? Oh no, it's people.
People, yeah.
People dot map dot
Well, not name. So what is each of these things inside of this array?
Names.
I would call it a person.
So
right?
we'll do. Okay, we'll call it.
Let's call it person.
Oh no, we're gonna call it a peep.
Okay, sure. You can call it whatever you want. But that is one thing that's inside of the array. Cool.
Yeah, so peep is going to be returned as it's going to be peep dot first name and peep dot last name.
Okay, you're making lots of typos, but I'll help you out. Peep
Sorry.
No worries. Last name. Cool. And so this will give us, and actually let's log it out. Let's see what we get. So there is no space in between them. So how would you add a space between their first and last name?
Okay, well we could do the fancy way, but
The template literal, yeah.
I don't.
We don't have to though.
Yeah, but I'm gonna do it the old school noob way.
There you go.
There you go.
Yep, so we get an array with just the full names in it. Cool, and that was that trick of like using property access inside of the function like we did before. Okay, this next one, create a new array with just the names of the animals. So we have this animals array that has name and size, and we want a new array with just the names of the animals. Okay, so animal names. Animals.map. And then each thing will be called, what is each thing in that array? Are you there, Tony?
Can you, we have to call it something different, right?
Yeah, so it's not named, so it's like what is each of those things? And typically it's like the singular version of the name of the array. So like what is each thing in that array?
It's an animal.
Yeah, so let's use that.
So it is an animal. It is a function, and it needs a body. And right. No. What is happening?
There's a lot of delay. Let me help you out. Oh god. Okay, let me help you out.
Yeah, sorry about that.
No worries. Okay. So what?
So we're gonna return animal dot name.
Cool. If this works, I want you to rewrite it as a single line function. That works. All right. How would you rewrite this as a single line fat arrow?
Okay. Let's make Amazon happy. rid of the... Do I not need that anymore?
You don't need the return anymore either.
Oh.
And you don't
That
need
was
the
like something else.
semicolon inside of it. Yeah, and that should do it.
Boom.
Boom. All right. How many more do I have? Okay, this this one is super hard. I think we'll skip that one, but I do want you to do this one because this one's interesting. So remember that ForEach had access to the index and the array, but I want you to take this array of numbers and create a new array of objects with the properties value and index. So value should be 4, and then index should be 0, and that'll be inside of an object. Like let me give you an example of what we're trying to end up with. Like I want objects where value is 4, index is 0, and then I want another object where value is 8 and index is 1, etc. So I want an object like that for each one of the values in this array.
All right, I got you, fam. I got you.
All right,
okay.
Check it out.
So content better numbers, or let's call this specific numbers.
Okay.
Which is the numbers dot map number dot index, and I need to get both of those gentlemen in a house. And then it's a function now. It has a body and as a thing, and we're going to return
so we want to return an object.
So we're going to return it. Hey, can I do backtick? There we go.
Why are you going to do that? So we want to give the object 2 properties. So it needs a value property and an index property.
Oh, I kept thinking like you wanted me to actually make it look like that value and index.
No. So it's an object with 2 properties.
So literally just gonna do number and index, or excuse me, index.
Not quite. So
no.
Okay. Without using number and index, give this object 2 properties and like set them to an
okay. Value. Do I put? Do I put like?
Well, you can just use what you have available to you. So what do you want value to be?
Oh, okay.
Yeah.
So number, and then index is index.
Yeah, I think you did it, Tony. Let's see. Specific numbers. All right. There you go. So interesting thing. So in ES 2015, if you're creating an object with a property where the value is the same thing, you can just get rid of that, and that will do the same thing. And,
that looks a lot better.
And then if we wanted to do the same thing here, we could just call this value because we can call it whatever we want. Now we can just do value comma index. All right. If we wanted to turn this into a one-liner, though, it gets tricky because if you want to return an object from a one-liner fat arrow, you have to wrap it in parentheses. Because look, if we tried to do this, what this looks like to JavaScript is like, okay, I've got a fat arrow, and hey, okay, now starts the function body, but then inside of it, you're just doing this. If you want this to actually return an object, you have to wrap it in parentheses. So this is now like a one-liner that returns an object for each map, like that. Yeah?
Got it.
Cool. All right, Tony, you're a trooper. You have hung in there for an hour and 46 minutes. This has been awesome. And we're kind of building our way up. We talked about first class functions. We talked about identifying higher order functions. We got some practice with ForEach and kind of got used to like using a function to iterate over an array. Then we talked about the accumulator pattern and how really all of the things that we're doing with map, filter, and reduce are some sort of accumulator pattern. Like we're accumulating up to some value. And then lastly, we just talked about map. So in your own words, Tony, what is map? So like what does map do? What do you give it? What do we get back?
So essentially map is like a way of taking some sort of variable and then, oh man, how do I even explain this? It's kind of like doing for each, but in a cleaner way. Does that make sense?
Okay, that's a good way to start. So what does map return? Like what do you get back from a map?
You get back the item, you get back the index in the array.
Well, here. So like what is lazy days in this example of a map?
Oh, lazy days is a whole new array.
Yeah, so ultimately the thing we get back from like the whole map is a new array. And then what does the function passed into a map return, and how is that used?
Essentially takes some sort of parameters that we've and applies it to the first array to create essentially the new array.
Yeah, and new values. So like in the example here, we're giving it a function that takes in a number and multiplies it by 2. So if we run that function on every value in the array, we get 26, 84, and then whatever that is times 2. And this is a function that takes in a string, and this returns the first three letters of the string. So when we run every one of these values through that function, we just get back the first 3 letters. This is a function that takes in a person and then returns their full name with first name and last name separated by a space. So when we pass each of these objects into that function, we get back their full names. This is a function that takes in an animal and just returns the name of that animal. So when we run each one of these animals through that function, we get back dog, lion, elephant, cat, and we get a new array with all those values in it. And then this one, we have a function that takes in the index, also the value in the index itself, and we return an object with 2 properties, value and index. And then we run every single value in our array through that function to get back our array of objects. Cool. And to bring it back to kind of like this diagram, it's like you have your input array, you have some function that you're going to call on every value in that array, and then you have your resulting array, which is all of the results of calling that function on every element in the array. Okay, we've done it. I will push this code up. So all of this code is on the Coding Garden organization under this project called Higher Order Functions. It is linked in the description, and in a future episode, we'll finish up with filter and reduce. Tony, thank you so much. You are a trooper. You use lots of brain powers. Hopefully it all doesn't sink away and you remember some of this stuff next time. I
think I'm gonna go do some code katas.
Cool. Any takeaways, any words of wisdom, like anything like you took away from talking through all this stuff today?
Well, I mean, with big takeaway with all this is it's just kind of like almost like reinforcing some of the stuff that we've done with just building apps, because it's like I've built like simple stuff on my own and with you, but most of it's like using kind of tutorials and whatnot, and a lot of times it's like I know how this works, but I don't understand how it works on a bigger level. And so I guess
this kind of like narrowed the focus and like focused in on those things.
Yeah, it like basically explain like how some of these functions work, like doing the API calls, like what's happening under the hood, and just all this stuff in general. Like I told you, like I asked you about the hackathon thing, and like stuff we've done on this like made me somewhat useful on my team.
So can you just talk about that?
All this has definitely helped.
You decided to
Oh
participate
yeah,
in a
so
hackathon, and yeah.
yeah, so this past weekend in Columbus there was the Smart City Hackathon, which is basically this big push to essentially put Columbus on the map because they won this big grant to help make Columbus into a smart city, which in a way is kind of a different concept depending on who you talk to. But the whole thing was a way of showcasing this thing that they have called the Smart Columbus operating system, which is basically like this big repository for different databases, which I think you should be able to go to like smartcolumbusos.com and you could
I think I'm on the
see
website,
some of that.
but can you kind of like talk about your experience there? Like you have a bit of experience like writing apps, and you were able to like contribute to your team and kind of like talk about
Yeah,
that.
so like I went to the whole thing. Like I kept thinking like, all right, I'm gonna plug Vue.js because I've been doing some stuff with that. That never really came up in a way. But basically, like I understood how an app should work. So big big picture, I was able to contribute to that conversation and talk about like, okay, I understand how we would build an app and all this different stuff. So um, picked the use case that I was interested in. My team was working on a parking meter problem, but basically trying to create some sort of correlation between like high demand uh, parking areas and using essentially the parking data that existed and seeing if there's any correlation.
Hello?
Can you hear me?
Yeah, you still there? I just heard like a loud noise.
Yeah, I don't know what happened.
Okay.
But um, basically what ended up happening was um, got together with a bunch of people. We were kind of talking about all this ideas of like user experience, user stories, like how would this app serve anybody. We had all these conversations about should we try to fake data, should we just use data that exists,
Yeah,
and there was all these
I think the biggest takeaway though that and like what kind of why I wanted you to talk about it is like you don't have that much experience building apps, but you were able to get on a team of people that have like a ton of experience and actually contribute, and they welcomed you and like kind of mentored you and like paired with you to learn to code more things, right? I think you did Python or
yeah. So like one of the things we were using was Python, and I was able to work a little bit in that. Like I never really messed around with Python syntax a little while, about like a year or so ago.
mm,
Just doing basic hello world type stuff, but just knowing like what I know about JavaScript, I was able to actually contribute to the project.
definitely.
And then I built the whole thing, our little Python app. I kind of just I didn't really know how to serve it up. I think I asked you about it. There was different solutions to serve Python in a web browser, but I ended up just using an iframe
Mm.
and
Like
had
to
like a
embed
real
it in
basic
in
web
another
page.
website that you had. Yeah.
Yeah, so basically, like I went on CodePen and shamelessly took somebody else's like simple fake multi-page solution,
Mm.
and then I essentially had our little app in the center of the page, and there was like
Nice.
multiple pages that said different stuff.
Cool. But main reason I had you talk about that is like if you're out there and like wherever you are, there people are having hackathons and you've coded a little bit, like don't be afraid to show up to those events. Like you'll find people that are more than happy to like bring you onto their team and like pair with you or help you out or like you know enough to be successful. There are some messages in the chat. Yeah, I actually do have Quokka. For these, because I was working with Tony, I didn't necessarily want to run it, but Quokka is super great. Um, it will actually evaluate a lot of your console logs, so you don't have to run them in the terminal and like show them in line. Um, and some plugs. So me and Tony pair every Tuesday, and so if you check out the playlists on my channel, you can see some of the past episodes where we actually built real apps. And a lot of times we do use like map and filter and things like that, but we've never really taken a step back and like dove into like what are higher order functions and how do these things work. So check out some of those episodes where like we're actually building real things. In this episode, we didn't get through all of the exercises as we had planned, but we got through a lot, and Tony learned a lot, so it was a good time. And I guess also to mention, if you do just want a like a quick down and dirty like what is array map in JavaScript, I do have like a I think it's maybe 13 minutes long. It uses some of the similar exercises that we just did and kind of just really breaks down like what is map. But yeah, as I mentioned, link in the description to all of these exercises. You can give them a try, follow along to the video. And in an upcoming Newbie Tuesdays, we will finish up with filter and reduce. Huge thanks to everybody that tuned in and participated in the chat. Yeah, anything else to say, Tony, before we end this?
Not much. Thanks everybody.
Yeah.
See you guys next week.
Thank you, Tony. You're a real trooper through this. I realize we really stretched your brain muscles in the past 2 hours or so.
That's all good.
Cool. All right. I am going to be streaming tomorrow. I'm going to be doing solving code katas. So for that stream, I actually do have a GitHub repo where you can recommend katas for me to solve. So if you check out the code katas repo, under the issues, you can add a new comment if you have any that you'd like me to try. If I don't get any, I will, before the episode tomorrow, post in the description which ones I'm going to do. So if you do want to follow along and try to do them while I do them, we can do that as well. Check out coding.garden for my full streaming schedule. Streaming tomorrow, streaming Thursday. And I think that's it. Thanks everyone for tuning in. Thank you, Tony, for hanging out with me, and I'll see you next time. Here is this.